All right. Good morning, boys and girls. Today, let's talk about your card sort activity that's going to happen on Monday. Typically, this is really easy to do on paper, but it gets a little bit more difficult when you have to do it virtually. So we're going to have to, you know, make some changes. All right. So just to review real quick, there are chemical formulas that determine how things happen, like oxygen and hydrogen makes water. How these plants, this is a little wilting tree limb that I found, a little sprig of tree takes carbon dioxide out of the air. So it takes CO2 and it separates the atoms and pulls out the carbon, and then it builds itself into our tree like this. Okay, it continues to grow. It pulls the mass out of the air from the carbon dioxide and then turns it into a new element, and we are looking at these compounds that they're forming. The octet rule says the reason atoms do what they do is that they are ionizing, they are gaining or losing electrons in order to satisfy the octet rule. So they want to gain, lose, or share electrons to get 8 in their outermost energy level, or they're going to drop down to a full energy level. Now, we've not talked about sharing yet. That's covalent. So we're just looking at the gaining and losing in ionics. Okay, so we've looked at valence electrons. It's the ones in the outermost energy level. And we can look at our cheat sheet to see how that works. And I'm going through this really quick because this is the notes we've already done. Ionic bonds are when they are donating electrons. So we've looked at the ions. This one's going to be a -3 since it's already got 5 and it wants to get to 8. It's going to steal 3 electrons. It's going to steal 3 negative charges and form a nitrogen of a -3 charge, which is an anion. Negative charges are anions. Positive charges are called cations. Oxidation numbers are another way of we write that those ions have. So lithium and sodium are all in the same column, and so is potassium. So anything in the same group in that same vertical column, they have the same oxidation number. That means the charge that they form. Again, we showed how all of this stuff on our cheat sheet is based on the arrangement of elements on the periodic table. So since all of these have 2 valence electrons, they all form an oxidation number of +2. They form a cation of +2 because they lose those 2 valence electrons. And the last notes we looked at were drawing Lewis dot structures, and they look like this. We just put little dots. Now, let's put all of this together and look at ionic bonding. I'm so excited. All right, here's what happens in bonding. First, we have to do the electron dot or the Lewis dot structure. Okay, we looked at that yesterday. Nitrogen has 5. We practiced these: hydrogen, carbon, fluorine, and phosphorus. They all have these dots around them representing the valence electrons. Okay, so now we're going to do this to show bond formation. So here are the steps. This is on slide. Ooh, I'm going to have to look and see which slide number that this is on. I have not added these in yet. Let's pause for a second. Okay, so this is actually slide 6 on your interactive notebook. So again, go to your Google Drive. You can search for the Unit 2 Bonding Interactive Notebook. Hit View. Come on, View. View. Zoom. 100% usually works. So on this, we're going to look the steps up and put them in here so you can use them for your quizzes and your exams. Again, put them in your own words. The first thing we're going to do is draw the electron or the Lewis dot structure of the elements. Okay, and we'll do an example of this too. Next, we're going to transfer electrons. We're going to use little arrows to show from the metal to the nonmetal, because ionic bonds are usually metals and nonmetals. Draw an arrow showing that the electron is getting donated to that other element. Because again, remember, they want to get 8 valence electrons or drop down an energy level. Next, we're going to add additional elements if we need to, because sometimes it doesn't always work with just one of each. And then we can continue to transfer electrons until all of the atoms are stable. And then a last step, I swear. Write the chemical formula using the subscripts to show how many elements it takes. The reason it's CO2 is it's a carbon and 2 oxygens. So we have CO and then a little subscript of a 2 to show that there's always 2 oxygens for every carbon. Okay, let's look at an example after we pause to get our notes. All right. So remember, use your cheat sheet. I've actually put it in the presentation here, and it should be attached on today's video as well. Remember, our valence electrons are on the bottoms of each of the columns in blue. But the first thing we're going to do is here's our first example. Now, you don't have to put these in page 6 if you don't want to. If you want to take a screen grab, though, of this finished product and put it in your interactive notebook, please do, because that's where your quiz questions come from. What compound is going to form between sodium, which is Na, number 11, and chlorine, Cl, which is number 17 on the periodic table? First, we draw our symbols. Sodium only has one valence electron, chlorine has seven. So on the actual card sort Monday, there will be a bunch of little green dots down here you've got to drag and put where they need to go. But I'm going to drag one, two, three, four, five, six, seven. Okay, now chlorine really wants to get another valence electron. Sodium wants to get rid of its valence electron. So on Monday's card sort, there will be another little batch of arrows down here. You can drag an arrow up and then manipulate it to show that this valence electron on the sodium is wanting to go to this chlorine. Okay, this shows that sodium is going to get rid of its valence electron, chlorine is going to accept it. And what element did we form? Well, all of the electrons off the metal have been donated, so it only takes one. So to get salt, sodium chloride, it's just NaCl. If you don't see a subscript, you assume there's one of each element. It's simple as that. Let's do another example problem for an element that does not have one of each element. So example 2, what compound is going to form between aluminum and chlorine? So aluminum has 3 valence electrons. It's in group 13. It's in that one group close to the metalloids. Chlorine is still atomic number 17, so it's still going to have 7 valence electrons. So aluminum, we're going to put 3 dots, 1, 2, 3. Again, on Monday's card sort, you'll actually drag them up there. Chlorine, we're going to put 7 on each one. 1, 2, 3, 4, 5, 6, 7. There'll be a little grab pot of them, and you just woof, 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 move them up here. Now, here's the thing. Aluminum is going to try to get rid of all 3 of them and drop down in energy level. Chlorine is going to only take 1 so that it fulfills the octet rule. So I'm going to put an arrow on here showing, okay, boom, we transfer that. But the aluminum still has 2 more electrons that it needs to get rid of. Here's what we got to do. That means one chlorine is not going to cut it. We need another chlorine to take that valence electron. Uh-oh, we need another chlorine to take that valence electron too. So if I mix a bunch of aluminum and chlorine together, just the atoms off the periodic table, it's going to take 3 chlorines to bond with a single aluminum in an ionic bond because it's got to get rid of those electrons. Okay, last step is I need to write the formula. I know it's going to be AlCl, aluminum and chlorine, but I need to put a little subscript on there to show that chlorine, there are 3 of them for every 1 aluminum. It's like you're writing a chemical formulas recipe. It's 1 part aluminum, 3 parts chlorine to make aluminum trichloride. All right, so AlCl3. There will be a bunch of subscripts on Monday's card sort, and you'll have to drag that subscript of 3 up there onto the Cl to show what the formula is. Okay, practice time. This is going to be what we're doing on Monday. We're going to be manipulating these, and let me actually take you over to that so you can see what we're doing on Monday. The example problems that we did today will be on the video walkthrough. This is showing you how to manipulate the arrows. This was example problem 1. This was example problem 2, where we have to take and drag the arrows and move them in here. And then there's also a fully worked out problem. This is where the little green dots are going to be. We're going to drag the green dots up there where they need to go, put the arrows in, and then drag the subscript up there to show that this would be beryllium dichloride, BeCl, and now I grab that 2 up there to show that there's 2 chlorines for every beryllium. Okay, so again, on Monday, your card sort will be a Google Sheet. You will get a copy of it, and you'll have to come in here. This is example problem 1. You're going to have to literally drag these dots up here. And then when you want to show one of them's being donated, you'll grab the arrow, move it to show that it's going here. And again, there's a big bunch of dots and a big bunch of arrows on here. and then you can just grab them and move them as you need. But that's it, boys and girls. So remember, if you have any questions on Monday or today, I will on Monday when you do the card sort, I will be on Google Classroom the entire time, and you can hop in at any point that you need help, and I will come help you out. You can share your screen. Remember, if you or anybody that you know needs help, call 866-393-6659. You can text or call that number. Boys and girls, have a good day. We will I wish they would quit announcing stuff left and right. Okay. Anyways, boys and girls, have a great day. I will see you on Monday. Have a great weekend.